So today we're going to be talking about waves. So a wave is a disturbance in a medium. A medium is a material through which waves travel. A medium can be water, as I've got here. It can be air, etc. Now, a wave transfers energy without transferring matter, and I'm going to show you that with the water I've got in this container here. So as you can see, still I'm going to now disturb this medium so that the wave travel in it. Okay, so you can see the water moving, so it's transferring wave. However, it's transferring energy. However, there's no transfer of matter. You can see is that water is everywhere, it's just that the energy is being transferred. There are two categories of waves. We call it transverse and longitudinal. So I'm going to show you using this slinky what transverse wave is and what a longitudinal wave is. So a transverse wave is a wave in which the particles or the oscillations move perpendicular to the direction of energy transfer. So in a transverse wave, the oscillations move perpendicular to the direction of energy transfer. So what I'm going to do is I'm going to hold one end steady and I'm going to disturb the medium on one end to show you what a transverse wave look like. So I'm going to move my hand up and down, and what you can see is a wave being formed. Now the particles are moving up and down, or the oscillations are moving up and down. They create the wave, but the energy is being transferred from one end on the left to the other end on the right. So examples of transverse waves are like water waves, electromagnetic waves, etc. Now we have another category of wave called the longitudinal wave. So in longitudinal wave, the particles move parallel to the direction of energy transfer. So the particles move parallel. So here's a demonstration. I'm going to hold one end still again. So the particles move back and forth and energy is being transferred parallel to that. What you will notice is that there are parts where the spring comes together, we call that compression, and parts where it's spread out, we call that rarefaction. Okay, and then there's some parts of a wave, so like you have the amplitude. So we're going to now label different parts of a wave. So here we've got the wave as shown by the red line. We're going to first label this arrow here, which is the amplitude. The amplitude is the distance between the undisturbed or the equilibrium position and the crest. The crest is the highest point. So I'll label the crest on this side, which is the highest point of the wave. We have the wavelength, which is the distance between two consecutive points that are at the same stage of motion. So that's the wavelength. And we have the trough, which is the lowest point of the wave. Okay.